So this is a Tesla turbine. The general concept is that we could run water through it and generate electricity. Right now we have water running through the bypass valve, so should we not want to run water through the turbine, it can go ahead and just go through the bypass and nothing's generated. When we close the bypass valve and we open up the turbine valve, we can run water through the turbine, which rotates fast enough that it then turns the generator motor here, and we generate electricity to potentially run the whole system off of. When we generate 5 volts is at the point that all the LEDs on the bank there will flash and it will buzz, letting us know that we are self-sustained and we can turn off our alternative source and run off of our generated electricity.
And open the turbine to 50%. So right now it's opening the valve to the turbine so that a little bit of water will be able to flow through it just to start it up. After this, I'll close the bypass valve. After that's closed, it should have all the flow going through the turbine, and it should start to spin the motor. Do I want to close the bypass? Yes. So our motors are not very torquey, so we had to do gear ratios just so that the valves could close, but they are still pretty slow to.
We don't have a very constant water pressure here, so you'll hear the motors surge because it depends on how much water is flowing through and at what pressure.
So right now we have the water that's running through the turbine. The bypass valve has been closed, so all water is running through here. We have 16th-inch holes that are drilled out here, so as the water flows through, it then shoots in between discs that we have evenly spaced at 1/8 of an inch. The 16th inch then spray of water grabs the discs, uses friction to rotate the shaft. In the middle of the shaft we have it hollowed out so that all the return water then would come through the system, back out the flow end here. We have residual water that blows through, so to get that water to come out we're using this tube here.
So we have an output display option that measures the voltage and gives a proportional reading on our LEDs here. So right now we're spinning at about 208 RPMs and we're generating about 3 volts.
And it's 208 at the shaft, so that's around 600 RPMs at the generator.
Should we get 5 volts, then all the lights will come on, will flash, and we'll get a buzzer that alarms us we've reached our desired output.
And now I'm going to go ahead and use the jumper to our 5 volt source to simulate if we are getting 5 volts, and I will re-request an output display. So as soon as we're generating 5 volts at 241 RPM and 5 volts. So at this point we could take our power source off and run completely off of this, but we're not generating enough flow at the moment. So we have 2 main microcontrollers that are controlling our project. This is our PIC A. This is pretty much receiving any user input from the keypad and on-off switch and displaying anything that the user selects on the LCD and gives a proportional value there. But anything that is sensed on the project, such as our tachometer or voltage, is read by our second PIC here. And so these 2 PICs are continuously communicating back and forth, sending information. Got a voltage bank here that's then broken down into what's needed for each component. Our generator actually outputs AC voltage, so we had to go through a full bridge rectifier before going into our main circuit. So the voltage that's generated by the generator is then read by our A to D converter, and then is then read by this PIC, is sent back over to our main PIC, and then displayed to our LCD to the user. So instead of using the main PIC microcontroller such as the 88 or the 84 that's used in the lab, I decided to go with just the basic stamp. This is a BS2E, and that's just a BS2. They're the main microcontrollers provided by Parallax. This one's already integrated into the board, and it has a programming port right on it, so I can have a debug window and serial communication to my computer as I'm using it, so it's a lot easier to debug the program.